is Chaitanya, Physics faculty at Shakthi International School. In this video, we will learn an important topic of class 11th work per energy chapter, that is vertical circular motion. Vertical circular motion. In this vertical circular motion, we are going to analyze three important cases. That is, first one, object oscillating in lower circle. Second, object moving to upper circle but not able to complete the circle or oscillation. And the third one, object completing the loop or oscillation. Object completing the loop or oscillation. Okay. So first thing, let us understand what happens in this vertical circular motion. Let's say this is the circular path we are having. If there is a rope and to that rope a mass of body of mass m, this is a mass m attached to it at this point. If I am giving some velocity here, it is going to reach different positions. Let's say I am taking at some particular point of time, this is the point where the object is. We are trying to analyze the first case. Let's say it has displaced by an angle theta. From here to here, the angle is theta. Now to analyze anything in this condition, we have to draw free body diagram of it. Tension will be always in upward direction here, and mg will be acting in downward direction, vertically downwards. So here mg is acting vertically downwards, and if you are resolving it into components, this will also be theta since alternate angles are equal. We can write this direction of force as mg cos theta, and another force is in this direction, which is mg sin theta. This force can be written as mg sin theta. We are resolving it into components. Now tension is in upward direction towards the point of suspension. If you are analyzing what are the forces acting here, tension is acting in this direction, mg is acting in this direction, mg cos theta. But whenever an object is performing circular motion, it will experience a centrifugal force or a centripetal force. We are considering here in this condition a centrifugal acceleration or a centrifugal force, which is can be written as mv square divided by r. So I have to write there is another force which is acting in this direction. Since the object is neither going away or not falling into that circle, the forces should be balanced. You can write the equation of tension as T is equal to mg cos theta plus mv square divided by r. This is the general equation of tension for the object which is performing oscillation in the lower circle or which is moving in the lower circle. Now, since we know what is the value of tension, we have to understand, okay, what is the velocity. Now it is not necessary that it is always going to be completing. There should be here whatever the velocity that we are giving, okay, at the initial point. Let's say you consider this one as point A and this one as point B. We know we should be giving initial velocity VA so that it might be reaching point B. Now we have to analyze what should be the initial velocity you will be giving so that it will be oscillating in that particular cycle. Okay, if you are giving more than that velocity required, it will go to the upper circle. If you are giving lesser than that, then it will be oscillating in the lower point, okay, lower circle. Now to analyze this, we are going to use the help of conservation of energy. Conservation of energy. In this condition, you know, at the bottom point, okay, when the object is here, when the object is at the bottom point, and it might reach the maximum point of this one. At any point of time, if you want to analyze at this particular point, the final velocity will become 0 if it is stopping. But the tension should not be 0 in this condition. Why? Because if the tension is becoming 0, then it will be slacking. In no point up to this lower half, tension will never become 0. You know velocity VA is the bottom velocity. It should be reaching this point B and it should be stopping. That is when it will be oscillating in the lower circle, or else it will be going beyond that particular point. Now, if we are considering this as our analysis, if we are using this as our analysis point, here the forces acting on it are different. We are analyzing in terms of conservation of energy. So initial energy that it possesses here is kinetic energy initial plus potential energy initial. Here the energy that it is possessing will be kinetic energy final plus potential energy final. Since kinetic energy initial can be written as half m into Va square, then potential energy of it is 0 because this is the reference of your ground. Okay, from here it is not at any particular height, it is going to be 0, and the distance from here to here is going to be radius r. Okay, so that means the kinetic energy in the final position will be 0, since final velocity at point B we are considering to be 0, and the potential energy can be written as mg into h, where h is the distance that it is covering in upward direction, that is r. So now, since we got what is the velocity that we needed, we can calculate what is the velocity we needed from this equation. Half mv square can be written as mgr. So mass and mass gets cancelled. Velocity a at the point A, speed at the point A can be written as 2gr. So Va should be root 2gr. That means the maximum velocity that you can give at point A to reach point B is root 2gr. If you are giving, if Va is greater than root 2gr, then object will leave the lower half. If velocity initial is lesser than, if Va is lesser than root 2gr, then it will be oscillating in lower circle. Okay, so the minimum velocity that you can give in it can be anything from 0 to root 2gr. The maximum velocity that you can give is going to be root 2gr if it has to be oscillating under the lower circle. Next condition, if we are analyzing case 2, in this case 2, we have to give obviously greater than 2gr, root 2gr, because if it has to enter into that, the velocity initial that we are giving should be greater than root 2gr. Let's say the same condition, initially it is having a mass m. Okay, that means mg will be acting in downward direction. The radius of it is r. Let's say it has reached this some point. It is now moving in the region of B to C. A to B we have already analyzed, B to C we are analyzing. Let's say it has come to this location. Let's say the angle from the vertical is theta. So here tension will be acting towards the center. Weight is acting in vertically downward direction. So if it is acting vertically downward direction, if this is theta, I can take this one also to be theta. So that means if I am resolving it into components, then we can write the force acting in this direction as mg cos theta. So the now equation becomes, now in the outward direction we are having mv square divided by r force. So we can write T plus mg cos theta should be equal to mv square divided by r. Now this is the condition of tension. So previously the tension formula is different, now the tension formula is different. Make sure you are understanding the difference, that the angle that we are taking is from the vertical, not from the that means in the upper half cycle, not from the lower half cycle. So this is the tension formula we are having now. Okay, the velocity that you are going to give here is going to be Va. We are not analyzing it yet. Now the object that it is going, the velocity that it is going to have at this particular point, we don't know. Let's say it is going to be v. If it has to stop at this point, if it is not completing the cycle, that means it should be stopping from between b to c somewhere. Let's say the maximum point that it can go is up to c. That means at c, if you are considering velocity to be 0, okay, the maximum um, point at which the velocity is becoming 0, that means it is stopping at this point. If it is stopping at this point, it is not able to complete the circle. It is going to return back, or it is going to, since the tension is going to becoming 0, the string will slack and it will be falling down. Now in this case, we have to understand from b to c, if you are writing the equation t plus mg cos theta is equal to mv square divided by r, that is a tension equation. That means tension can be written as mv square divided by r minus mg cos theta. Now if you are using the kinetic energy equation, okay, if you are analyzing from it in terms of va, let's say here in this condition, if you are equating the distance from here to here is r, and the distance from here to here, since it is going to be theta, this is r, you can write the side length from here to here as r cos theta. So that means this is r cos theta. The total height from the bottom can be taken as r plus r cos theta. The distance from here to here can be taken as r plus r cos theta. So if you are trying to analyze kinetic energy initial plus potential energy initial should be equal to kinetic energy final plus potential energy final in this condition. Okay, so kinetic energy initial is half mva square plus potential energy is 0. Kinetic energy final is going to be half mvb square plus potential energy is mg into r plus r cos theta. So this is the equation you will be getting. So now if I am cancelling all the m terms, we will be getting va square is equal to vb square plus 2mg r plus r cos theta, 2mg into r plus r cos theta. This is the general formula we will be getting for va. Now va square is equal to vb square plus 2mg into r plus r cos theta. If it is moving, if it is at point B, if the object is at point C, then theta is going to be 0 degrees. Then you can write Va square is equal to Vb square plus 2mg into r plus r, which is 2r. So we can write this as Va square is equal to Vb square plus 4mgr. Now we have to understand what is Vb square. Now you know that the final velocity at that point, if it is becoming 0, okay, then only it will be stopping at that point. If you are substituting that, the tension to become 0, in that condition tension will become 0, but velocity should not be 0 if it has to be moving. If I am equating that, t is equal to mv square divided by r minus mg cos theta. In cos theta condition, theta is going to be 0 when it is at point C. At point C, theta is going to be 0 degrees. So T is equal to mv square divided by r minus mg. So if tension is becoming 0, you can write mv square divided by r is equal to minus mg. So mv square divided by r is equal to mg. So gets cancelled, v square is equal to rg. So in place of v square, if you are substituting this, that is vb square, if you are substituting this equation, the value of velocity at point A, va square, can be written as 5, obviously we are having mg also here, okay, vb square 5 mgr, 5gr, sorry, 5gr. Now we have to remove this value of m here, we have written, okay, which is being deleted. So this m is also being cancelled here, 2m, in all the cases m is getting cancelled. you don't have to bother about this m. From both the sides we have already cancelled m, so it will not be, you don't have any m value there. So final velocity that at point A you should be giving VA is equal to root 5 gr. That means if you are giving VA is equal to root 5 gr, then it will go to the maximum height. That means it will go to point C and stop. It will not be able to. That means if your velocity is greater than root 2 gr, okay, and velocity at point A is lesser than root 5 gr, it will be oscillating in the middle circle. When it is going to be completing it, when velocity at point A is greater than root 5 gr, then cycle will be completed. Okay, that means a loop will be completed. So that's how the vertical circular motion is analyzed. So I hope you understood the different velocities. Now if you want to re-understand it, relearn it, the initial velocity that you have to give here, VA, okay, is equal to root 5 gr if it has to reach a maximum height, if it is to reach point C. Then if the initial velocity that you are going to give at point A should be equal to root 2 gr if it has to reach point B. This is point A and this is also point A. If it has to complete, okay, that means if it has to go from point A to again point A, if it has to come in this direction, then the initial velocity that you have to give, this is point B, this is point C, and this is point D, let's say, okay, initial velocity that you have to give if you want to complete the cycle is equal to root 5 gr. Okay, I hope you understood this. Thank you.